I'm Rohit Girdhar and I'll be presenting our work on task relevant features for image matching. So let's start by asking the question, are these two images taken at the same place? Well, we as humans can easily tell that that's indeed the case, but how did we do that? We focus on parts of the image that are most relevant to the task at hand, in this case localization. So we are able to find that castle in the far background in both the images, and we can easily say that they are indeed taken at the same place. In this work, we essentially try to develop this ability to automatically find parts of image relevant to the task and then improve the task by using features focused on those parts. Specifically, we focus on the task of retrieval-based localization and try to find parts of the image that are most useful for this task. To give an overview of our approach, we first start by extracting multiple patches from the image. Specifically, we use selective search bounding boxes. Next, we score each of these patches based on their ability to find other images taken at the same location. So for this specific patch taken over Chichen Itza, we are able to retrieve other images also taken at Chichen Itza, and hence this is a good patch because it's able to retrieve images taken at the same place. In contrast, another patch taken from this man's face would retrieve other images of faces, but not necessarily from Chichen Itza, and hence this is a bad patch for the task of localization. So this gets a low score. Finally, we train a model to represent these patches. We specifically use a support vector regressor and basically train a model on the FC7 features of these patches and the scores they obtain on training data. And finally, at test time, we use these. We do the exact same thing of extracting patches from the training images and score them using the model learned above earlier. And we show that this method of doing patch-based retrieval performs much better than previous state-of-the-art key point-based retrieval approaches or other CNN feature-based retrieval approaches, such as using the full image features or using other CNN representations such as MOP CNN from ECCV 2014. Moreover, our method is not only limited to a CNN patch-based retrieval approach. We can also convert the scores we obtain over patches into a heat map-like representation, as shown here, and we can use this to improve any existing key point-based retrieval approach by simply focusing the key points on the high-scoring regions of the heat map. We introduce a new dataset for this task called the people at landmarks, which is different from existing retrieval datasets such as Oxford 5K in terms of having large amounts of clutter in the query images. It also represents how people naturally take images in front of landmarks. Finally, to some results. These are some of the predictions of our method on some test images on what it believes is the most useful part of the image in terms of for the task of localization. And as we can see, it does a pretty good job at that. Quantitatively, our method outperforms other means of finding interesting regions in the image, such as using saliency or using exemplar SVM. And we also show that our CNN patch-based retrieval approach outperforms other CNN retrieval approaches, such as using full image features or using MOP CNN and other representations. We also show that our method can generalize across datasets. So a model trained completely on people at landmarks is applied to the Oxford 5K dataset, and we show that it furthers the state-of-the-art on that dataset, whereas it's not even trained on it. And we note that the performance is smaller because the dataset itself does not contain much occlusions, and usually the object of interest is in full view. Finally, we try to understand what did the model learn. And here I show some of the top ranked and the bottom ranked regions according to our regressor. And I also show some of the patches that activate neurons corresponding to positive and negative weights in our regressor. And we can see that it tends to believe that patches from building facades or from dome-like structures tend to be more informative in terms of finding the location of the image, as opposed to using patches from faces or other random patches from like sidewalks and trees and so on. Thank you.